So hi everyone, we're back here at the VM workshop virtually here in 2020. And our next session is user experiences in setting up OpenShift on ZVM. We have Sam Cohen here. I've known Sam for a number of years. He's not just book smart, but he has a lot of hands-on experience. So it's always good to hear from him. With that, I'll turn it over to you, Sam.
Well, thank you, Bill. Well, to all of you who are listening to this and seeing it live or on recording, good afternoon, good evening, good morning, or what the heck are you doing up this late? This is the last presentation on this day, and so I'm not sure which is worse, the one before lunch, the one right after lunch, or the one when everybody wants to go to get some refreshments, but it is what it is. Let me just explain a little bit about why it's not paging down. Okay, I love technology. There we go. Okay, a little bit about myself. I was with IBM almost 30 years, and now I'm with Levi and Shoup. It's one of the premier IBM business partners, and I've been working with VM, VSE, and Linux pretty much my entire time working with IBM. And I've been working with Linux on Z since it was before the standard distributions were out there, just because I was curious. What you see is a picture of me because a family project we have is training service dogs. And these guys were here at the North Rim of the Grand Canyon last summer. Right now, that area is closed, combination of COVID-19 and wildfires up there. It's great fun. So, because I'm curious, IBM has put a lot of emphasis on OpenShift with their Red Hat acquisition. And I was wondering, okay, it's out there for Z. What does that mean? Hey, it's under ZVM. Okay, what does that mean? So I figured I would try, since I could get a demo download and try it for free for a period of time to see what it would take. Now I happen to have, because LRS has a ZOS and distributed product called VPS, one for it's a print management system, originally out for ZOS, now also for Linux, Windows, etc., including Linux on Z, by the way. So I happen to have a Z14. I maintain the demo environment for the organization and have a ZVM 7.1 environment in an SSI cluster. Excuse me. Under that, we run ZOS, ZVSE, and pretty much every distribution of Linux out there. Including some, I won't say roll your own, but I was trying things like Fedora, OpenSUSE, etc. So I'm trying to figure out all of this. Luckily, I have a lot of experience with Linux because there's a bit of Linux knowledge required in getting this set up, because it involves not just, it's not an appliance. You have to set up DNS or modify a DNS to add your environment. So you need domain name services. You're going to need to have a load balancer. You're going to have a DHCP, eventually DDNS. So the ability to do a lot of this stuff to support it. So I was trying to see what was going on. I took the Red Hat documentation, discovered that, like many docs, it was written by people that knew too much. So I figured I would help myself out to try to learn it and try to help others so you don't have to go through what I went through. I can't address in this session what you're going to do with this once you build it. Your Kubernetes-centric colleagues might go, wow, you could do this. And I'd say, fine, well, it's there. I have no idea what you're going to do with it now that it's laid out. That's their job. I do have to give credits to two different folks. One is Michael Benson for an explanation in Enterprise Tech Journal last year and I do have permission to use some of his presentation materials. And Philippe Miranda from IBM, he came out with a LinkedIn presentation on how to do just what I had been working on for better off and on for 6-8 weeks, and not getting anywhere because the Red Hat doc was missing a lot of stuff. And so he filled in a lot of gaps. I worked with him one-on-one and explained what my issues were, coming at it from a VM sysprog and Linux person, not a container dude, not a Kubernetes dude. And so he helped clear up some of that. And then right after that, he came up with a second paper to describe the network settings. And I'll go into some of that because in this world, well, to me, it's weird. So save it that way. So again, my first point was to try to understand OpenShift better. Kubernetes, I kind of understand. It's a deployment and management engine, but in this world, instead of deploying containers, it deploys pods, which sounds like something out of a bad Roger Corman movie. But what a pod is, and this is coming from Michael's definitions, it's a business app that is one or more containers. So they basically said one container could be one pod, or you could have a whole bunch of containers, and then that makes up a pod. And then a service is a collection of pods that are distributed amongst these workers, so you can spread stuff out and get the load balancing and not worry about a single point of failure. Then there's, in this case, the concept of a node. A node is a virtual machine or a Linux guest. And there's two types. There's a master node that does the scheduling and controlling, and then a worker node, which is really where the pods, i.e. the services, actually do their thing. And then there's this thing called a kubelet. And that is essentially just a communication mechanism between the master nodes and the worker nodes. He also provided a picture, and the pictures made a lot more sense to me. There's some things in here that still I kind of look and go, huh? Like this Etsy daemon or daemon. I'm not quite sure why it's called that. I'm not quite sure how it's used. This is one of those Kubernetes people would understand that. I guess it's a name that came from that environment. I could be wrong, but I can only fill my head so much with this stuff. But ultimately, every rectangle or square, if your monitor is askewed, is a virtual machine. And so you see that the work goes on in the worker nodes. The scheduling is up there and the controlling is up at the master nodes. And then there's something outside of this. And that's I would have had to have gotten other people involved. And I didn't have that luxury because I'm kind of have to run this whole domain. So a little more detail. When it's deployed out, we have these master nodes, worker nodes. It uses something called Core OS. Core OS used to be independent, and Red Hat bought them. And so it's even a smaller, tighter, lighter weight than Red Hat Enterprise Linux. And so the first thing that happens in the process is you have to build a Bootstrap node. It's another virtual machine. That guy ends up containing stuff that the master and the worker nodes will pull in when they're building out their environments. Every one of these nodes start up the same way you would start up SUSE, Ubuntu, Red Hat, and that is you have 3 files up there in your reader. One's the boot, one's the parm file, the other's the initRD. And that's basically how we get Linux going. And once that comes up, then there's a pointer as part of the parm file that points to something called an ignition file to get the fire going, if you will, which that ignition file says, hey, pull this in, pull that in, pull these in, pull those in, to build out that image. You could kind of think of it as another variation of AutoYast or of Anaconda, which is what Red Hat uses to sort of build a common image. In this case, that's what these ignitions do. The way these ignition files get built is they use some kind of a markup language. I don't care what it is, but it's called YAML, which is a recursive acronym of YAML ain't markup language. I actually looked that one up. So YAML means YAML, and there you can end up getting sucked down a black hole. You can think of it kind of like XML. There's a tag section and a value section, but it is incredibly picky. Positional input, it's very picky as to what goes where. So just be aware that in the instructions, if you take a look at them, the positions, having an extra space can hurt you. So in my demo environment, I had to create a layer 2 vSwitch. Demo VM2 is one of my 2 members of my SSI cluster. And I did everything in here. I had to create a network services virtual machine, the Bootstrap dude, 3 masters and 2 workers. I was not able to give myself a new network, and I wasn't going to approach my network people because this would have taken even longer. What I have to work with in my demo environment is basically a /25, the upper half of a 10.96.64 and then .120, you know what I mean, 128. And so I can go from 128 up through 255. And what I called this to build my network services guy, I was going to have my own DNS, my own name server. Internally, we call ourselves lrsinc.org. So I called this domain, the subdomain, if you will, OS demo. And then I had to create an additional domain just for this environment, which I called demo cluster.osdemo.lrsinc.org. And the reason I'm telling you this stuff is because it'll become important later, especially when you're setting up the YAML. Now, the other thing is this Kubernetes service network. And the reason I said that's internal, this was my point of confusion. I thought that I had to take this 192.192 network and break it up even finer. Or I'd have to go say 192 for 16 and then go, the next 16 up above it. Well, it turns out that screwed me up because my thought of a network is, okay, it's another network. It has to be under my control and reachable from the outside world. And that actually was incorrect. Let's go in and by the way, ultimately, I was going to be able to do a live guest relocation of some of these and move them around. That was my ultimate goal. My ground rules for getting started, I was going to put no firewalls. I had to set up a layer 2 vSwitch. That was a condition of this environment. I had to work with my existing network. As I mentioned there, the .128 for 25 bits. My gateway, for some reason in our corporation, they put their gateway all the way at the top instead of all the way at the bottom. And the network people told me later that they actually reserve 250 through 254 for their use. 255 and IP rules is always reserved. So what I was going to do was put in FTP, DHCP, DDNS, and my load balancer all in one virtual machine that would do all of this stuff. I'm also, by the way, limited on disk. So luckily I have FCP attached disk, and so I decided to use that. That's a difference from what the Red Hat doc or Felipe's doc does. He used DASD. Not too much of a difference. The biggest difference, at least at this point in the demo, or in this setup, is that I can only have single path. Multipath wasn't available yet. Of course, in ECKD, all of that pathing is controlled by the IO subsystem. But in the Linux world with FCP, if I'm going to have multipath, I have to have a multipath daemon up and running. And at this point of getting this to run, which was 4.2 of OpenShift, they didn't have that support. So the next step I had was to register and download OpenShift and print out the documentation. I have the hyperlinks there if you ever want to try this yourself. I set up basically a layer 2 vSwitch. This is exactly what I had in there. And I actually have in both members of the cluster, my OSA is at 0200 through 22F. I already had 220 through 222 in use for my layer 3 vSwitch. So I took the next, made him a layer 2 vSwitch for the next set of OSAs on the same port. System had no issue one way or the other. But again, I was not going to get into the VLAN world, so I'm VLAN unaware. Again, much more stuff here than I'm going to go into at the moment. What I will say is I tried to highlight the things that were different between a master node and a worker node. The biggest difference between them is my master node has an 8 gig virtual machine, while my worker node has 16 gig. And I gave myself some standby so I could grow or shrink that on the fly if I needed to. Of the 4 types I had, the network services was what I called OS. All these guys start with OS for OpenShift. So my DHCPD has all the functions. I only needed 1 engine. I made him 2 gig. My Bootstrap, only up when I'm creating this guy, came up looking like the master node. And by the way, that's 4 virtual engines. But 8 gig. The workers, again, 16 gig, again, 4 virtual engines. So again, 3 masters, 2 workers, 1 Bootstrap, and 1 network services guy that was going to act as my FTP, DHCP, DDNS, etc. Since I happen to be, I'll admit it, a SLES bigot, and the reason I'm a SUSE bigot is because I can't remember all those syntaxes that you need for other distributions that require you to have system programming knowledge. I use YAST all the time. So I used YAST to configure my DDNS, my DHCP, my FTP, and they have a load balancer in there. They don't use something called HA proxy. They use NGINX. Looked like the same kind of functionality. It was part of the whole package. I figured I'll try it. What can hurt? So I created a DNS with YAST, which had my subgroup. I put in my DNS entries into the appropriate zones, those OS, DHCP, etc. When Felipe's paper came out and said, I used HA proxy, I thought to myself, could that be causing me an issue? Do I have to use Red Hat versus SUSE? So I built another server based on RHEL 8.1, but I borrowed out all the configurations that had been done by YAST and SUSE for the DNS, for FTP, etc., because I wasn't about to reinvent that wheel. But I did have the HA proxy. The configurations that Felipe provided did work. So I kept bouncing back and forth. And I'll tell you about that when I just have to give all of this background so that you know what the results are. Download the OpenShift code. Part of that is something called a pull secret. Based on your registration, it creates this secret file you have to pull down. And so what I did is I pulled all that down, and I had to have the pull secret. And then I defined, because if this was referenced in the Red Hat doc, to create a user ID called core. And the reason I had to do that was so that I could create an SSH key so that I could then log in if I had to. I could shell into the Bootstrap guys, the master guys, the worker guys, and it would give me the ability to connect in, and then I can use sudo to run root privileged commands. Core would do that through the sudo. So to create these ignition files, I do pull in these files, get my pull secret. I had some issues where brackets were missed. I was having some other things where an FTP translation did give me a little bit of problem. So it turns out during part of this, I was missing a bracket. So I had to use something like a JSON verifier to verify that I had all the curly braces, delimiters, etc. But once all that was done, I then created this thing called an install config YAML file per Felipe's doc, not in the Red Hat doc, to add an architecture. And then I had to embed the pull secret and the public key that I had generated for the user ID of core. One quick note, that is when you start building these ignition files, it eats up that YAML file. So if you don't want to have to type it again, be sure you keep a copy. And again, don't change what they have for the cluster network and the service network. Let's go into what this YAML looks like. And I know it's tiny print, but I wanted to go into part of this, and I have in red to show you what I had to put in and how these matched up to the DNS. My base domain was for the DNS domain. The instructions said don't put any number on the number of work replicas, but put in 3 for the number of masters. I can tell you what I did. I can't tell you why. The metadata, the name is demo cluster. So that was, and this maps back to my cluster here of the masters and the workers will be democluster.osdemo.lrsinc.org. The cluster networks came with it. I didn't change it. Well, I did change it originally, and I thought the cluster network meant my the network between the masters, basically the masters and my FTP and DNS server. And I thought service network meant between the master nodes and the worker nodes. And I was totally wrong. These are all kind of pseudo things. And one of the times I finally noticed that it kept saying, I've run out of, when I had this only as like 6 addresses, or 6, it said, I don't have any more IP addresses. It was trying to build a crap load of IP addresses internally, and I couldn't control it. So I just left this alone with Felipe's help. He said, don't change that. And I'm going, why not? Because the term to me, cluster network and service network, meant something different than to the people that wrote this stuff up. The other thing down at the bottom, pull secret, that's where, within quotes, the contents of the pull secret, SSH key, the contents. So if your pull secret has a double quote, you'd have a quote on the front end, a quote to the back end, and if there are double quotes in the middle, it doesn't matter. You have to leave all those in place. So then you run a couple of scripts. And I had all of this running on my FTP / the one network services dude, who is also my FTP guy. On him, I ran the OpenShift install, had to modify the master schedules to false. This is in the Red Hat doc. Executed to create these ignition configs, and it creates these 3 called Bootstrap, Master, and Worker. I did discover that I ended up having to change the ignore and set them world readable. Sorry, I wish I could have. Ignition configs. These ignition files had to be made world readable. And the reason for this is because I needed to set up anonymous FTP so that the Bootstrap coming up would get this info. which meant that I had to, now what I had is I put all these files under /mnt. And then in /mnt, I did a bind mount to the anonymous FTP locations in SLES or Red Hat, /serve/FTP in SLES, /var/FTP in RHEL. And I had to set up my FTP to allow anonymous. Now, when you're building all this stuff, it comes up with security certificates that are only good for 24 hours. So you can't just set this up and come back a couple of days later. It's not going to work. So you really have to sit down and focus on this. So the first thing I did is I built the Bootstrap machine. It took me a while to get the parameter files right. And this is very lacking as far as I'm concerned. It's a little bit like trying to read the Red Hat doc to figure out the parm file for Red Hat. What I have in here is what I used for my Bootstrap. Again, I'm using FCP attached disk, so it's not DASD A, it's SDA, SCSI disk A. My FCP is the single WWPN and LUN0 that's going to be on address 2000. If you're not familiar with this, if you don't have FCP attached storage in your environment, this could look pretty weird. And you're right, it is kind of weird. Notice that there's a pointer for the ignition URL for FTP, and there was nothing in there for putting in a user ID and password. You could structure this URL to have a user ID and password in line, but I decided to use anonymous. That .193 is the address of this FTP server. And notice I'm pointing to this thing called Bootstrap Ignition. The installation image is one of two types there. And notice this is 4.3.18. When 4.3 came out, I updated this to go from 4.2 to 4.3. And this is one of two gzip files that is the image. There's one for ECKD and one for fixed block. The ZNet of QETH, that's the one output. It's going to have a virtual switch connection. It's layer 2. I set the IP address of the Bootstrap to be .194, then the gateway, a net mask, a name, and I don't know what the last one is, and then what my name server is. And again, I'm pointing back to my FTP server because he's the name server for all of this. There's a nice limit inside of Red Hat when you're reading a parm file. And that is, it's only going to accept, I think it's 480 characters. So I had to take this that you're seeing spaced out, and because it's a fixed 80, because it is a card image, I had to do my split join key, PF9 by default in Xedit. And at each line, I would have to join them up. So it's essentially one continuous stream of 80-column characters. And I did try, because one of the things you can do in Red Hat is point to a CMS mini disk and a file. That's this thing called a config file. Doesn't work because they're not using Red Hat. They're using this miniature environment, the core OS. So in case you were thinking of that. Once the Bootstrap was up, well, I had to then build the masters. Now, I had to build, what I did is I built a unique parm file for each one. In this case, I accessed my my SDA disk was going to be on a different WWPN. I'm now pointing to an ignition called master, and there's one master ignition file for all the masters. And then my IP is going to be different, and the host name was going to be different. Now, you may notice here that the name I gave it here is master 0. That was not the name of the virtual machine. I tried having the name of the virtual machine as this host name, and then I put in a CNAME parameter in the DNS, in other words, an alias. It sometimes worked, it sometimes didn't. So I decided to make the host name what the doc said these virtual machines were supposed to have for a host name, and then I created an alias for the virtual machine name. OS Master 0, OS Master 1 are now the CNAMEs in my DNS. But Master 0 in the DNS points to that .195 IP address you see here. For Master 1, again, I had to verify my pathing, my WWPN, different IP, different host name, etc. And for the workers, same concept, different ignition, and different name and IP. But the bottom line, the big pain here was making sure that my WWPNs were correct, because they tended to flip on me depending on where the system wanted to go. If I didn't have them correct, it would not find SDA, and I found out about that by watching it trying to come up. So here in microprint was kind of the action that was going on. Started with the create manifest, here's the editing of this cluster scheduler, create the ignition files. I xautologged my OS boot, and I watched it using SCIF, Secondary Console Interface. And what I was watching for was when it started to mount some additional file systems. And I could do that because of a kind of a bug that's in there, and I'll mention that in a moment. So I was watching it. Once it came up, it would reboot. I could shell to OS boot from my FTP server that had all the code in it. I was using the user ID of core. I had switched user to core, SSH to OS boot. I'm watching this thing called Kubernetes service. I got the hint about through SCIF that it was pretty much done, but on the bootkube service, I actually saw something where it's sitting there and it was waiting for the etcd cluster. That told me I had to get my my master guys up and running. So basically, I got my masters started. I xautologged those. I xautologged my workers. Waited quite a while. And eventually, when my masters were all built, I would actually get this bootkube service complete. Meanwhile, back at the ranch, in the back here on my FTP, etc. server, there's this command to do this wait for Bootstrap complete. That could wait up to 30 minutes. Sometimes it did, sometimes it didn't. Ultimately, this became consistent, where it said, okay, you can now remove the Bootstrap resources. At that point, I could signal shut down the OS boot virtual machine. Then I had to update my load balancer to take the OS boot out of there. Now I could check on the status, and a lot of this was in Felipe's presentation. I've just copied some of it to show you what it looked like from my perspective. You can see the request store. There's references here to master 0, master 1.os demo, etc. And no wonder it ran out of IP addresses. There was all sorts of junk mucking around here. So then the last thing I would do is I would do this wait for install complete. When it was done, it now said, hey, you can go in, you can export, you can run OC. The really cool thing I tried then was to say, can I open up a browser and point to this thing? And it's this name, and you notice this name is an app inside the democluster.osdemo.lrsinc.org. And it's a good thing it told me the admin and the password, because you gotta write that on a slip of paper. Who's going to remember that silly thing? Anyway, so that being said, I did have to update my my browser, actually my network settings in my workstation, to point to the osdemo.lrsinc.org IP address as a DNS, so that it would go there, so it would look to resolve that. And when it did, I actually was able to get in and see things graphically. It immediately told me that I was one level down on 4.3 and 4.3.19 was available. And all I had to do was push one button to start it. And so I started it. What the heck? What could go wrong? Haha, famous last words. And sure enough, it updated everything except master 2. And at that point, I said, I can't debug this because it's way beyond my pay grade. So I blew that all away and put it all back to 4.3.18. So what did I learn? Well, there was a while where I could not log in as core with that, with this SSH agent. There's mentioning here. I had to create a little exec that does this eval and SSH add in my. So I switched. I would usually log in to root. I know you're not supposed to do that, but I would switch user to core. I would run a little script that did these 2 commands, and then I could SSH to my Bootstrap or master 0 or master 1 or worker 0, and it would connect over fine. I did try, just for fun, I took my core user ID and I actually took what was in Etsy Shadow for the password, and I was able to put that into the YAML, and then I could actually just do a shell directly and type in a password. But that's outside the instructions. It's not in any of the YAML stuff directly. So I wouldn't recommend that. Better to have this little exec that you can put in. You could actually put it into your .pro file if you wanted to when you come in as the user core. The key for me was, my clue that I mentioned there in the second set of small bullets. There was a message, an annoying message called SE Linux mount invalid. It doesn't hurt anything. As far as I'm concerned, I consider this like an error that, an expected abend. How can you have an expected abnormal? Because that would mean it's a normal abnormal, and my English grammar teacher is screaming in my head when that happens. But that being said, I use that as an indicator of, okay, I'm starting to see that watching the Bootstrap server. And so now it's time to start up my master and worker, because it's far enough down the path on the Bootstrap that they won't be sitting there saying, are you ready? Are you ready? Are you ready? Are you ready? Otherwise, they go back and forth a long time before everybody sort of agrees that both sides are ready. Again, I handled anonymous FTP, so I did a bind mount. All my files were in /mnt, and I mentioned this on rel or sles. I had to change the permissions. I set there is a subdirectory in /mnt. It was a subdirectory called auth that was built as part of creating the ignitions. And so I discovered that I might have to make that guy world readable to read the subdirectory. I don't know if that was really true or not, but I was running out of time. So I was lazy. It's sort of like logging on to root all the time, right? I mentioned that CNAMEs didn't always work. So that's where I switched to CNAMEs. Those are the aliases in DNS language. Because I was using SCSI disk, indicate user will not tell you anything about IO counts. So it's hard to tell if you're just stuck, because something might be sitting there doing a ton of IO and not using much CPU. And since there's no counts when you're FCP attached, that makes it a little on the tricky side. Now, what happened to SLES versus RHEL? I really prefer SLES, but NGINX had a weird configuration compared to the HA proxy. HA proxy, you could say, hey, if you see anything on ports 80 and 443, that's HTTP and HTTPS respectively, you could just route it. NGINX wanted some kind, it wouldn't allow me to do that kind of a thing. It had to have something with an HTTP tag. And so rather than try to investigate or become any more confused with NGINX syntax, I just said, no, we'll just keep it rel. Another thing, though, I did use YAST to build the DNS dialogues and the configuration file because bind 9 is common. Bind 9 is the release of the name daemon. But YAST does not like putting an asterisk in the DNS config file. And that's a requirement to put in a wildcard for these apps so it knows how to route them and to route them to multiple masters. And so I had to manually update the DNS config. And again, if that's something you're not comfortable with, it takes some practice. I'll leave it at that. So if I had been able to get NGINX working, I probably would have, but oh well. If anybody knows NGINX better, they're welcome. Please provide updates because, again, I had DDNS available, I had DHCP available, all through SUSE and Red Hat. I was not going to become a systems programmer and try to figure out what to do with RHEL's version. As a result, though, the cluster was successfully built. I was able to relocate virtual machines between my SSI members. The graphical interface worked, and now somebody else gets to figure out what to do with it. That pretty much is it. I have not been looking at the chats too much. Are there any comments or questions that anybody has?
Yeah, so if people have questions, feel free to unmute yourself and ask them or in the chat. I didn't see any unanswered things in the chat, but if you had one there, feel free to speak up.
Wilhelm, when I looked up YAML, it said YAML, another markup language, but I like the yet.
Great experience, huh?
I learned a lot. And I learned that I don't know. This really, what I think I learned really from this is doing this on your own is really tough because you have to know a lot about a lot. Especially in the distributed world, I mean, let's face it, as a VSE person, you have to know a lot about a lot. Because you have to know a bit of KIX, a bit of SNA, a bit of IP, a bit of NJE, RJE, all this stuff. As a VM guy, you end up knowing a lot because of IP, security, as was mentioned earlier. There's a lot of stuff to it. Here in the distributed world, it looks a lot more like the ZOS world, where there's people are really deep, but they're not very wide. And so the challenge is when you have to be wide and deep.
Well, the way towards, or the path, is to make it simpler or to make it automatic, right? The requirements that are challenged are the ones that are beside the OpenShift cluster itself. It's the DNS, it's the DHCPs, these kind of things which basically not necessarily have something to do directly with OpenShift. It is the services that OpenShift needs and is expecting to be there.
Right. And luckily, in my case, I've built DNSs before, and I relied on SUSE to make sure everything was in sync between DNS, DDNS, DHCP, all of that. The nice thing is it did most of the heavy lifting for me.
Uh-huh.
And that's something that Red Hat is getting better at, I will say. I like RHEL's desktop that you can get automatically to manage it more, but it's still nowhere close to YAST, in my opinion. Not that I'm biased or anything.
All right, then Sam, I thank you very much for sharing your experience here and passing that information on to us.
Thank you.
Thank you.